Hello, students. Good evening. Welcome to another class of Vedantu Karnataka. This is Catherine, your physics master teacher. Quickly let me know in the comments if I'm audible and visible. Yeah. Hello, students. Oh, yeah, I can hear myself. Hello, how are you all? Lakshmya, Rakshita, Shashank. How are you? How are you, Bharati? Balraj. Did you all have your dinner? All of you had your food? Lunch, dinner? How are you all? Quickly. Yes. Are you all in a mood to study physics at 9 o'clock at night? Huh? Sudden plan D. What's happening, Lakshmi? What happened? Yeah. Quickly let me know in the chat how you all are doing. Students, we have a scholarship, a Vedantu scholarship. It's called the MV-SAT. So it's a Mega Vedantu Scholarship Admission Test. Okay. Now, if you want to become a national champion, you have to go to our offline centers. Okay. The dates for the offline exam are 4th, 5th, 11th, and 12th. Now, if you're someone from Bangalore or Karnataka, our center is in JP Nagar. Okay. So make sure you write an admission test because you have crores of money waiting for you. The prices are, you have scholarships worth rupees 150 crore, 2 crore, so many different things. Okay. So spread it to all your friends who are all, smart and they're all waiting for an opportunity. This is yours. Grab that as soon as you can and make sure you attend the offline exam. What are the dates for the offline exam? Yes, it's on 4th, 5th, 11th, and 12th October, JP Nagar if you are from Karnataka. Okay? Hi, Sanjay. I remember you. Hello, Sunny. How are you all? How are you all? So, students, last week I was doing second PUC. So, we looked at electrostatics. Okay? So, today we will be looking at some first PUC chapters. So, today I will be doing units. Alright? So, all of you know units and dimensions is a very easy chapter. Okay? And you will get one or two sure questions from units and dimensions for KCET. So, in one class, okay, in one shot, I will solve all the previous year KCET questions from units and dimension and make the theory crystal clear to you. That is the aim of today's class. Okay. So all the previous year questions I've included in today's session. We will be solving all of them. So all of you know at least some percentage of your questions are from first PU. So even if you're a second PUC student who's forgotten first PU, watch this. So this class is for both first PU and second PU KCET aspirants. Okay. Are you all there? I am fine, Sunny. Thank you so much for asking. Okay. Let's start. Is my video stuck, students? Is there a lag? Can you please let me know if there's a lag? Yeah. Okay. So all those who joined late, the Mega Vedantu Scholarship Admission Test is going to happen on 4th, 5th, 11th, and 12th. Okay. So prepare well. Go give your best. Earn lots of money through scholarship. And you can get great ranks, free online study material, free online courses, one-to-one counseling. There's a lot waiting for you. Okay. Hi, Sunita. Thank you, Sunny. Thank you so much. Students, is my video stuck in between? Because on my phone it is. Can you please confirm? Can 3 people quickly confirm if my video is getting stuck in between? Okay. So units and measurements or units and dimensions, you can call it whatever you want to. It's a very simple chapter. Okay. Okay. Let's quickly finish the chapter. So first thing that you need to know in this chapter is what is a physical quantity. What is a physical quantity? Are you a physical quantity? Is this cup a physical quantity? A physical quantity is anything that can be measured. For example, the length of this pen. I can measure it using a scale. That is the physical quantity. But the smell of this pen, I can't measure it. That is not a physical quantity. Physical quantities are things you can measure. But I can measure the temperature of the pen. So that is a physical quantity. Okay? For example, you get angry at your friend. I can't measure how angry you are. That is not a physical quantity. Okay? But the amount of sound coming out of your mouth can be measured. That is a physical quantity. So physical quantity is anything that can be measured. Okay? Is that clear? Yes? Is that clear, dear? I am fine, Sunny. I answered your question. Thank you so much for your compliment also. Alright? Okay, so that is a physical quantity. Now, a physical quantity. Can I buy phone for you, ma'am? What question is that, dear? I didn't understand your question. So, every physical quantity has two things. What all? First one, numerical value. Second one, unit. In simple terms, if you go to your mom, sends you to the shop and she asks you, go get 5 kilo of rice and come. So, you will go tell the shopkeeper, I want 5 kg of rice. What is 5? 5 is the numerical value. What is kg? Kg is the unit. So 5 kg in India is the same as 5 kg in America. It's the same as 5 kg in Australia. It's the same throughout. It's the same worldwide. That's why you have kilogram. Okay. So units tell us what you're measuring and how much is there and all that. Okay. So 5 kg is there, 5 gram. So if you have like few rice pieces, you're taking 5 grams of rice. If you have a huge sack, it's 5 kg of rice. So it tells us how much. The unit tells us how much is there. But if I simply say go buy 5 rice and come, what does it mean? Does it mean 5 kg or 5 gram or 5 pieces of rice? That's not clear. So every time you represent a physical quantity, you should put a number, which is the numerical value, and a unit. Now, when you go stand on the weighing machine, okay, let's not look at kg. Let's say my pen. Okay, so let's say my pen is 15. I say my pen is 15. What 50? Only if I write centimeter, it becomes clear that my pen is 15 centimeter long. So the physical quantity, quantity representing length is given as 15 centimeter. Okay. Now, if I say 15 meters, it's a long length. That is wrong. So, it should be 15 centimeter. Is that clear? Can you increase your voice a little bit? Yeah, I can. I'm not wearing a mic right now. But am I not audible, dear? 15 centimeter. Not audible? Quickly. Let me know if I'm audible or not. Yeah. All of you slept? 9, 12, you're all already sleeping. What is the physical quantity? Anything that can be measured. It should always be represented with a number and a unit. So in your PU or in your 11th and 12th, your teachers might cut 1 mark for not writing unit. They have the right to do that. Okay? Because whenever you write physical quantities, there should be a number and a unit. So next time, don't go to your teacher and say, ma'am, I wrote correct answer, ma'am, only unit is not there. Please don't cut marks. No. If I just say the length of this pen is 15, it does not make sense. Only if I say it's 15 centimeter, it makes sense. Okay? Alright. Next. What are units? I already said. It is like a universally accepted standard of measurement. So, kg is the same everywhere. Okay? Now, what are the importance of units? See, it's easier for you to compare. So, see, if you have a friend in, let's say you have a friend in, where do you want? In Canada. Okay. So, you tell your friend, I bought 5 kg of rice today. He knows what 5 kg of rice is because kg is the same here and there. So, it's easy for you to compare. Okay. So, if you have units, you can compare. And if three of you stand on a weighing machine and you can compare your weights because your weights are in the same unit. Alright. Is that clear? Now, units are of 2 types. Okay. So, units are of not 2 types, there are 2 kinds. Yeah, 2 kinds of units. The first one is called fundamental unit. Okay, the first unit is called fundamental unit. The next one is called derived unit. Okay, so what are the two different kinds of units? Fundamental units and derived units. Two kinds. And what is a fundamental unit? Fundamental units are basic units of basic quantities. For example, length. Length is a basic quantity. Length is not derived from anything. Length is length. Mass, time, all of these are fundamental quantities. You can't, simplify them. Okay? So the units of those quantities are called fundamental units. For example, what is the unit of length? Meters. What is the unit of mass? Kilograms. What's the unit of time? Seconds. All those are fundamental units. Now, what is a derived unit? Just like the word, it is a unit that you derive. Okay? It is a unit that you derive. For example, I say speed. So speed is what? Speed is distance by time. So it is derived from distance and time, and the unit is meter per second. So this is a derived unit. You look at distance. Distance is just length. It is not derived from anything. So it is a fundamental unit. Okay. So fundamental units are basic units. If you mix 2-3 fundamental units together, you will get derived unit. Okay. Is that clear? Hello Sahana. Hello Rakshita. Welcome to the lesson. Hello, hello, hello. Uta, Sahana. Hindi notes Bharatiya Akka. I'm sorry, I read it wrong. Hi, Shashank. Okay. So as I said, there are so many fundamental units. The major fundamental units that you need to know are these. Okay. So these are the basic fundamental units that you need to know. Okay. What all? Length. What is the unit of length? Meters. Mass. Unit is kilogram. Time. Unit is seconds. Temperature unit is Kelvin. Electric current unit is ampere. Luminous intensity candela. Amount of substance mole. Okay. All of these units you need to know. If you know these units, from these you can derive so many different units. Okay. Okay. Okay, let's look at an example. When we measure how tall a child is, we use meters or centimeters. We don't use meter per second or kilometers per second square or meter per second square. We don't use units like that. We use a basic unit either in meter or in centimeter. So that is why meter and centimeter is the fundamental unit of length. Okay? Is that clear? Yeah? Thank you, Sunny. Please share this video to all your friends, to all your class groups. Tell them to watch this video. Even if they're a first PU student or a second PU student, tell them by watching this one video, they'll be thorough with what they need for the KCET exam and PUC exam or 12th grade, 11th grade exam. Okay? Yes, yes, yes. Okay. Now, I've just put some fundamental quantities, their symbols, their SI unit. Okay, you can just take a screenshot of this. Okay, this will help you for your final exam revision. Quick revision and all, you can use this. Okay, now these three symbols are very important. Okay, I'll tell you why when we move on to that. You might already know for dimensions. So length has the symbol L, capital letter L. Mass has the symbol capital letter M. Time has the symbol capital letter T. Okay. Yeah, these three symbols you need to know. Length is L, mass is M, time is T. Students, these are the symbols. Okay. Not the unit. Those are two different things. Symbol, unit, two different things. Symbol is just short form. Length starts with L, so you just write, instead of length, you write L. But the unit is meter. Mass, symbol is M, unit is kilogram. Time, symbol is T, unit is second. Now, some of you might be thinking, ma'am, meter, centimeter is also a unit. Yes, but the SI unit is meter. So many units are there, but the standard unit is meter. Is that clear? Clear, clear, clear. Quickly, students. Did you all mark your attendance? How do you mark attendance in a YouTube class? Quickly, one of you let me know in the chats, how do you mark attendance in a YouTube class? Quickly, quickly. The first person to tell me the answer in the chat will get a shout out from me. How do you mark attendance in a YouTube class? Okay, so those are all fundamental units that we discussed. Now we will look at derived units. Derived units are when you add two or more fundamental units, you get a derived unit. Combination of fundamental units give you derived units. Okay, so these units are used to measure quantities that are not fundamental, like force. Yeah, force, volume, speed, all of those are derived from derived units, fundamental units. Yeah, fundamental units. Okay, so they depend on basic quantities like length, mass, and okay. Now, what is speed? I already said distance by time. Distance is a fundamental unit. Time is a fundamental unit. They combine to give speed, which is a derived unit. And the unit for speed is meter per second. Understanding? Now, force. Force is when you push something and something moves. Okay. So, the unit is kilogram meter per second square. Area is what? Side into side. So, fundamental unit into fundamental unit. Meter into meter, meter square. It's like that. Okay. Simple, no? Very easy. Yes. Is this easy or difficult? Quickly, 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 let me know in the chats. Did you all like the video? Yes, you mark attendance in a YouTube class by liking the video. Very good, very good. Quickly like the video. Quickly, quickly, quickly. Okay. Now this is a homework for you. Sahana did okay. Okay. Homework. You have to find out the SI unit of all of these quantities. Okay. Easiest one I'll do. Length is what? Meters. Volume also I'll do. It's meter cube. Okay. The rest you do and then you can let me know in the comments. Okay. If you've done this homework, in the comments you should say done. Okay. Yes. I look at how many dones I get. Students, none of you comment in videos. Why? See, it's 9:22 and we're still taking classes for all of you to give you wonderful content. Okay, so we pick up timings where you are all home and you are all free. Yeah. So the only thing that we want you to do is share this with your friends and in the comments let us know. If you didn't like the class, let us know that. If you liked the class, let us know that. No, good class, ma'am, or understood, ma'am, or ma'am, can you do this also? And all of that is what motivates us because we don't see any of you, dear students. Yeah. So please do comment. Yeah. Okay. Yeah, Sunita. So write the SI unit of the following derived quantities. This is also your homework. So to write the SI unit, you can either learn the SI unit. So as a first PU student or a second PU student, you should obviously know these units, and it's meters per second and all that. But otherwise, what you can write is, you can write on the formula. Speed is distance over time. Distance is unit, the distance has unit meter, time has unit seconds. Okay? Shashank, what did you write? Mama is all okay, I can see. Okay? Is this clear? Similarly, do everything. Okay? So density is what? Mass by volume. So it will be kilogram is mass, volume is meter cube. So kilogram per meter cube. That's how you write down the units of derived quantities. Yes? Okay? Now, some of you were asking me, ma'am, meter is not the only unit for length, the centimeter. Yeah, there's kilometer. There are so many units. Yes, students, I understand there are so many different units. Yes, and each system of units are called by each name. Yes, so they come as a pair. Okay, so you can see here, FPS system. FPS stands for foot pound second. That means if you're measuring something in FPS system, for example, I'm going to measure your mass, your height, and how much time you take to do something. Okay? So I will measure your length or your height in foot. I will measure your mass in pound and time in seconds. So if I measure your length in foot, I should measure your mass in pound. So because that is one system, that is like a group. Okay. So it's like three friends. If I call one person, I have to call the other two also. That's how it works. Now imagine you measure length in centimeter, then mass should be written in grams. Time always in seconds. Now if you measure the length in meters, then mass should be written in kilogram. Okay. So these are the different sets. So there's the FPS system, CGS, MKS and SI. What we usually use is the SI system, which is the International System of Units, where we use meter to measure length, kilogram to measure mass, time to measure second. So if I'm standing up and if I go for a health checkup, what they will do, they'll say that I am these many meters and I weigh this much kilograms and I take this much seconds to do something. That is how it will be done. Okay. Hi, YX Lava. Is that clear to all of you? Okay, my head was covering this. Now can you see? Can you see? Can you see? Okay. Why is it not showing live? Now it's showing. Okay, students, done? Okay, Sunita says yes. All right. Okay. Now, since from this, the system that we are using is the SI system. Yes. Since the system that we are using is the SI system, we will look at the SI units. Yes. What are the SI units? SI units are internationally accepted standard units for measuring anything and everything in daily life. So we already know there are 7 fundamental SI units. I already taught you this. Yeah. Length, mass, time, temperature, current, intensity, and amount of substance. And all of them have their SI units, meter, kilogram, second, all that. And these SI units have symbol. Okay. Now, if I say symbol for length is L, symbol for meter is M. Okay. Understand that. Symbol for mass is just M. Unit for mass is kilogram. Symbol for the unit is kg. Did I confuse you all together? Yes. So I can, if I simply say, what is the symbol for length? How do you represent length as L? But what is the unit for length? Meters or M. Okay. Yes. So this is very important, students. 7 fundamental SI units. See, they wouldn't ask you derive all 7 fundamental SI units. They may, but then for KCET, they definitely won't. But these are basic stuff that you need to know. Okay? Yes. Now, there are 2 more quantities which are called as supplementary quantities. Okay? So, there's fundamental quantities, derived quantities. Now, there's one more category, supplementary quantities. My God, what all are there, ma'am? You're wondering. Don't worry, this is the last. Okay? So, fundamental quantities are said basic quantities. Derived quantities are derived from fundamental quantities. Now, what are these supplementary quantities? Yeah? What are these supplementary quantities? Supplementary quantities are quantities that are neither derived nor fundamental. Okay. So they're not fundamental because they don't have any dimensions. But they don't depend on any measurement like mass, length, or anything. They don't depend on anything like that. Okay. They don't have any dimension. So they are not fundamental nor derived. So two such quantities are first one, plane angle and solid angle. Okay. So these are the examples. Plane angle and solid angle. So plane angle has unit radian, solid angle has unit steradian. Okay. Now what is a plane angle? If you have a circle and you take a small part of the circle, it makes an angle theta. Okay. So that is your plane angle. Theta is what? The length of the arc divided by the radius. See, this is the length of the arc and this is the radius. So theta is this by this. A is the arc length, B is the radius. Now same thing if I take a sphere, not a circle but a sphere, three-dimensional. Okay, imagine I take a sphere and I cut one piece. Okay, so inside the sphere, I cut one piece like a let's say like a pie. Okay, you cut one piece. So it's like a three-dimensional piece. So in that case, the whole area of the surface divided by radius will give you steradian. Okay? Yes. Yes, yes, yes. Do you understand? So there are fundamental quantities, derived quantities, supplementary quantities. Fundamental quantities, length, mass, time, blah, blah. Derived quantities, speed, velocity, and all. Supplementary quantities, radian, steradian, which are the units of plane angle and solid angle. Okay? Simple? Hello, Sumit Kumar. I remember you see every class. Sumit Kumar comes and asks me if I remember him. How can I forget you if you come and ask me every class like this? Sumit Kumar, this is first PU class. Why are you late? Yeah? Where are all your friends? Where's your teacher? Okay. So these are supplementary quantities, the two quantities which are plane angle and solid angle. Okay. Yes. Did you all mark your attendance? Quickly go like the video. All of you. How many likes do I have? Let me check that. How many people have liked? My God, it's just one like in today's class. Only one like. How depressing, students. Please, all of you go like the video. Why are you not liking the video? Quickly. Okay. Next is conversion of units. How we can convert one unit to another. So as I said, see there are so many systems. CGS system is there, FPS system is there. So many student system. So many different systems. So if there is CGS, centimeter, gram, second. So if you have 1 meter and they ask you to convert it into CGS, then you should convert it into centimeters. So 1 meters, you should convert it into 100. 1 meter is 100 centimeter. Now if you have 20 meters, what will you do? 20 into 100, which is 2000 centimeters. You understand? Okay. So 1 meter is 100 centimeter. This is how you convert. How was your physics exam, Sumit Kumar? Did Vedantu Karnataka help you score well? How many of your FA1 is over? Your FA1 or your first unit test or whatever name you call it. Okay, so you can convert units from one system to another. Now, next question. Convert 5 kg to grams. Okay. So, to convert 5 kg to grams, what will you do? Very easy. All of you know. All of you should know. Some of you might be saying, ma'am, if we know all this, why we should come to class, no? Yeah. So, all of you should know. From now on, all of you should know that 5 kilograms, sorry, not 5, 1 kilogram. 1 kilogram is 1000 grams. Okay. Students, how will you remember this? Imagine, what is 1 kilogram of rice? It is a big sack of rice. Right. See, you go to a shop, you buy 1 kg of rice or 1 kg of sugar. It's a big kit. But you tell the shopkeeper, give me 1 gram of sugar. He'll just take little with his hand and put it on your hand. Because gram is small. Kilogram is big. Okay. So, 1 kilogram of rice or sugar or salt is this much packet. So, should it be equal to little grams or lots of grams? It should be obviously equal to a lot of grams. So, it should be 1000 grams. So, I've heard a lot of students, telling me, ma'am, I'm confused. So, 1 kilogram is 1000 grams and 1 gram is 1 by 1000 kilograms, which is 0.001. Yeah. See, 1 gram means this much rice. So, it should be 0.00 kilograms only. Okay. So, now if you have 5 kilograms, how will you convert it? 5 kilograms will be big sack. So, how many grams? 5 into 1000 grams, which is 5000 grams. Okay? Is that clear to all of you? Yeah? No? Quickly let me know in the chats. Is it clear? Yes, no. Where is everybody? Where is everybody? How many of you are sleeping and already sleepy? Anyways, let me not, put you all to sleep. Okay, so that's how you convert from one unit to another. So a trick to remember, bigger the unit, smaller the number. Okay, so they're inversely proportional. So kilogram or gram, which is the big unit? Kilogram. So that is why 1 kilogram is 1000 grams. Bigger the unit, smaller the number. See, it's just like filling a water bottle. Okay, if you have big mugs, you need little mugs. So if you have big mugs, you need only 3 mugs to fill the whole bucket. But if you have spoons, you need hundreds of spoons. Think of units like that. If the unit is small, it should have a big number in front of it. I already said unit has 2 parts, numerical value and physical quantity has 2 parts, numerical value and unit. So if numerical value is big, unit should be small. Numerical value is small, unit should be big. Okay? Yes? So numerical value is proportional to unit. Okay, students? That is my new relationship that I am giving you. Yes? Numerical value is inversely proportional to unit. Okay? This is not something that they will ask you. This is just for you to understand. So whenever unit becomes big, for example, gram becomes kilogram. Kilogram becomes ton. Okay, whenever unit becomes big, the number in front of the unit becomes smaller and smaller and smaller. Okay, for example, I'll give you millimeter, centimeter, meter, kilometer. Okay, so unit is becoming big. Isn't it? Okay, so let's say there is how many millimeters should we put? Huh? So units are becoming big and big. The smallest unit of length is millimeter, then centimeter, then meter, then kilometer. So since meter is big, unit is becoming big, the value should be small and small. So let's say you have 100 millimeter. Okay, 100 millimeter is 10 centimeter. 10 centimeter is 0.1 meters. 0.1 meter is 0.0001 kilometers. So you can see here clearly when the unit is becoming big, the value is becoming small and small. Initially it was a big number 100. Now the number is very small. See 0.001 is very small. Okay. So this is just a relationship for you to learn. Okay. Yes. I think I shouldn't take classes this late. I don't find any of you, you're all sleeping and there's nobody in class. What is your suggestion, students? 9 p.m. slot? Is it too late for all of you? Haley? Is that how you say? Okay. Now, this is another very important table. Okay. I'll just move the camera so you can quickly take a screenshot. This is something that will be very, very helpful for all of you. Okay. So in questions in your KCET or in your PU, you will have these prefixes. Okay. So for example, giga. Giga means 10 raised to 9. So for example, they say the length is 9 gigameters. It means 9 into 10 raised to 9 meters. Okay. Giga means 10 raised to 9. Okay. So now if they say the power is 10 raised to 6 megawatt. Okay. That actually means 10 raised to 6. Sorry. If it's 5 mega. Okay. Let me write it. 5 megawatt is basically 5 into 10 raised to 6 watt. Okay. So, if this prefix is there, in order to convert it into standard unit, you need to multiply by these factors. Okay. So, you need to multiply it with the following factors. Now, if I say the student brought a 2 centimeter scale. Okay. So, if I say the student brought a 2 centimeter scale, that means 2 into 10 raised to minus 2 meters. Okay. Yes. Now, let's say that football track is 4 kilometers. That means 4 into the power 10 raised to 3 meters. Okay. So, if you want to convert any of these quantities to meters, you multiply with this factor. Okay. Now, if I say the small, what do I say? The chocolate was 5 millimeters, which means it was 5 into, what is the prefix? 10 raised to minus 3. 5 into 10 raised to minus 3 meters. As examples given here, 1 megawatt is 10 raised to 6 watt. Okay, 1 kilometer is 10 raised to 3 meters. Yeah, it's just given there. Okay. Okay. Are we on the same page? Yes, no. Some of you might not. I mean, I moved out of the screen for a second so you could see the whole thing. Yeah, you should, if you haven't taken a screenshot, go back, take a screenshot there. All right. I know my head will be there on your screenshot, so that's why I moved out. Yeah. Okay. Is it clear to all of you? Yes? No? Quickly let me know in the comments. Okay, let's look at another question. Convert 50 kilometers to CGS units. How will you do that? So there's actually a complicated way to do that and an easy way to do that. Okay? So there's a formula to do that. And the formula is this. What is the formula? N1 U1 is equal to N2 into U2. Okay? N1 into U1 is equal to N2 into U2. Now, what is N1? N1 is the value of the first quantity. U1 is the unit of the first quantity. N2 value of the second quantity. U2 value of the second quantity. Unit of the second quantity. Okay? For example, the question is convert 50 kilometers per hour into CGS. CGS means centimeter gram second. So, some dash centimeter per second. So here 50 is N1, kilometer per hour is U1. This dash N2 we don't know. Centimeter per second is U2. Is that clear? Yes? Clear? Yes, students, let me know. Come on, where is all your energy? Okay? So N1 is the value, U1 is the unit for the first quantity. Now you convert it into something else. So that quantity's value is N2, unit is U2. Okay? Is that clear to all of you? Okay. Now, let's, as I said, 50 into kilometer per hour into N2 centimeter per second. That we already got here. So what is the unit here? So 50 kilometer per hour is equal to N2 centimeter per second. And then what we will do? We will just do all conversion. So 1 kilometer per hour is how many meters? 1000 meters. And that is 100,000 centimeter. And 1 hour is what? 1 hour is 60 minutes. 60 minutes is 60 into 60 seconds. Isn't it? 1 hour, 60 minutes. Yes. 1 minute, 60 seconds. So 1 hour is 60 into 60, 3600 seconds. Okay. So this will be 50 is equal to N2. Yeah. 50 kilometer by hour is equal to 50 into kilometer becomes this many centimeter, hour becomes this much seconds. Okay. So instead of kilometer, I will write how many ever centimeter is there. Instead of hour, I will write how many ever second is there. And then I will do the math, I'll get the answer. Simple. Simple. Okay. So from this much part, you will not get, direct. I mean, I haven't seen direct KCET questions in any of the previous years. Even if it comes, it will be too easy for you. Great. You are all too smart for all this. So this was just basics. From now, we will start with dimensions. That's where your KCET questions come from. Okay. Like, ma'am, so you are fooling me till now. Okay. No, these are all basics. You need this. Okay. But I haven't seen questions, asking for that. But from dimensions, yes. There are lots of questions. We will solve every one of them. Okay. Now, what is dimension? Dimension is physical quantities or basic quantities which are raised to some powers to represent something. Okay. I know you didn't understand anything. I also didn't understand what I just said. Okay. So let's say there are 3 physical quantities. I mean, not 3. We know there are 7, right? 3, 4, 5, 6, 7. Yeah. Sometimes I also get confused. I was just joking. I know it's 7. Okay. There are 7 physical quantities: length, mass, time, current, temperature, amount of substance, and luminous intensity. All of these are basic quantities, isn't it? Aren't they? They're basic quantities. Okay. And they all have symbols. They all have symbols. Not unit, symbols. For example, length has symbol L. Mass has symbol M. Time has symbol T. Current has symbol I. Temperature is theta. Amount of substance is N. Luminous intensity is candela or Li. Okay. So these are all physical quantities and their symbols. So any physical quantity can have dimensions. Any quantity can have dimensions. Okay. And how will you write down the dimensional formula of a quantity? By writing the formula and bringing it into basic stuff. For example, it is defined as the power to which fundamental units must be raised to obtain the unit of that quantity. That is the NCERT definition. Let's say, for example, speed. Okay? Yeah? Let's say speed. What is speed? Speed is distance divided by time. Speed is distance divided by time. Yeah? Distance is a fundamental quantity. Time is a fundamental quantity. Now, distance is what? Length. How do you measure the distance? How do I measure the distance from your house to my house? The length. So, distance is basically length and time is just time. Now, I will write down the symbols for these. What is the dimensional symbol for length? L, but with a bracket. What is the symbol for time? T with a square bracket. Now I can take t to the top. So this will become L t raised to minus 1 with a square bracket. This is the dimensional formula for speed. You understand? How will I write dimensional formula? By breaking it down into basic formula and then writing the dimensional formula for the basic quantities. See, only length, mass, time, all of these 7 have dimensional formulas. You can't write down the formula for speed directly. You should write it in terms of length, mass, time, these quantities. You understand? Yeah? So, dimensional formula should always be represented with a bracket. Otherwise, it is wrong. Now, if you for your exam in a hurry, you go write L t raised to minus 1 and your teacher puts 0. Your teacher is not wrong. Okay? You will not get marks if you don't put brackets. Alright? So, dimension formula must have square brackets. We will look at some examples, then it will be a little more clear to you. Yes, Chintan Bus, 4 obedient students. Yes. You can also join. You can be the 5th obedient student. Okay? Is that clear? Okay. So, yeah. Generally, dimensional formulas are written in terms of length, mass and time. Okay. So, current and all that we don't usually use. Generally, it is written in terms of mass, length and time. Okay. Dimensional formulas are written in terms of mass, length and time. So, all dimensional formulas will be mass raised to some value, length raised to some value, time raised to some value. This is a dimensional formula. Now for speed, what is the dimensional formula? Mass is not there in speed. Speed is distance by time. There is no mass. So mass raised to 0. Length raised to how much? It is distance by time. So length is only taken once. Length raised to 1. Time, it is distance divided by time. So time raised to minus 1 is speed. See, anything raised to 0 is nothing. So even if you don't write m raised to 0, it's okay. M raised to 0 is what? 1. Okay. But generally, this is how you write a dimensional formula. Mass raised to something, length raised to something, time raised to something. I'll give you another example. Let's say there's acceleration. Okay. Once problem student says to write dimension, you need to know formulas. That is very important. Only if you know formulas, you can write dimension. Acceleration is what? Velocity by time. But I don't know the dimension for velocity. So what will I do? I will again write velocity as what? Distance or displacement. Okay. Displacement or distance, same thing. Not same thing. Vector and scalar, that's the difference. Distance divided by time or displacement divided by time. The whole thing divided by time. So distance and displacement are length, basic quantities. So now what will this become? This is basically length divided by time. The whole thing divided by time. So this is basically length divided by time square. So this is basically length time raised to minus 2. So what will the dimensional formula of acceleration be? M raised to what? 0, L raised to 1, T raised to minus 2 with square bracket. Otherwise, it is wrong. Okay? You should put square brackets here also. Okay? Is this clear to all of you? I didn't have dinner, Sanjay. I'll have it after the class. Okay? Did you have dinner? Did you eat? Yes. Okay. Is this clear? So, for acceleration, quantities like this, you derive it from the basic fundamental dimensional formulas. Okay. So, there are some dimensional formulas that I've given here. You can take a screenshot of this as well. Okay. And try to work it out. Okay. For example, force. What is force? Newton's second law, we all know that force is mass into acceleration. Okay. Now, just now we derived the dimensional formula for acceleration. What was it? Acceleration was, mass was not there. Acceleration was L t raised to minus 2. Okay, let me put m also. Acceleration was m raised to 0, L t raised to minus 2. Now, force is what? Mass into acceleration. What is the dimension of mass? Mass is just m raised to 1. So, what will the dimension for force be? Mass into acceleration. So, m raised to 1 into m raised to 0 is 1 plus 0, L t raised to minus 2. So, F is m L t raised to minus 2. That is what you have got here. Yes? Simple, but you need to know the formulas. Now, you don't have to complicate it this much. I just wrote down all the steps. So, m raised to 1 and m raised to 0 is just 1 plus 0. So, 1. It's not 1 into 0. Okay, see. A raised to m into a raised to n is a raised to m plus n. Math. Okay, that is why I did 1 plus 0. I'm sure all of you know that, but still, if there's one student out there who doesn't know it, it's for them. Okay? Is that clear to all of you? So, these are some examples of dimensions. Now, let's look at. Now, these are more examples. Okay, I didn't know I had put this much. More examples. So, can you see it because of my head? Let me just move out of the screen for a second. Okay. So, more dimensional physical quantities. So, you can see in all these, from the formula, I have derived the dimension. Let me do one more. Let's do power. Okay. Let's derive the dimension for power. So, power. Okay, we will do kinetic energy. I think I like kinetic energy more. Okay, let's derive the dimension for kinetic energy. Step 1. Write down the formula for kinetic energy. What is the formula for kinetic energy? Half into m into v square. Okay. So, one thing you need to know, these half, 2, 3, all these constants you ignore. For constants, you don't find out dimensions. Okay. Constants, you don't have to consider dimensions. So, half you don't have to take. So, you only have to take m and v square. So, what are the dimensions for m? M itself. Okay. What are the dimensions for velocity? We already derived. What was velocity? Distance by time. Distance is what? Length. Time is what? Raised to minus 1. But here it is velocity square. So, you put the square. Understood? You put the power, but you don't take any constant values. So now this becomes m L square t raised to minus 2. Did you understand this? So kinetic energy has dimensions ml square t raised to minus 2. If you have a constant in front, you ignore it. Okay? But if you have a power, you take it. Did you understand? Let me know. Yeah. Okay, let me do one more. Do pressure is equal to force by area. Let me do that also. If this is clear, I'll erase this. And I'll do pressure is equal to force by area. Okay. Yeah. Pressure is equal to force over area. Now, what is force? Force is not a fundamental quantity. So first I need to find out the dimensional formula for force. Force is mass into acceleration. Acceleration is also not fundamental. So mass into acceleration is what? Velocity by time. I can actually, make it even more simpler, right? By saying velocity is distance by time by time. Now I have it all in fundamental quantities. Now I can write continue right away, right? Mass is m, distance is l, and t becomes t raised to minus 2. Force. ml t raised to minus 2. Yes, correct. Okay? But you don't have to do this much. I mean, you don't have to write it, you don't have to write steps like this. This is just, for people who don't know any formulas. So what you can do is you can just write away, directly write. So F is equal to ma. So you can write m has dimension m. Acceleration is what? Velocity by time. Velocity has dimension lt raised to minus 2. I mean, acceleration has dimension lt raised to minus 2. So this is force. Area has dimension what? What is area's dimension? Area's dimension. Thank you, Sanjay, for all the fire emojis. Area has dimension side into side. So, side into side is what? Meter square. So, what will its dimension be? Meter is not mass, okay? Meter is length. So, L square. Now, what will pressure be? Pressure is equal to force divided by area. So, it will be M L t raised to minus 2 divided by L square. So, square and L will cancel. One L will go up. So, M L raised to minus 1 t raised to minus 2 with a bracket. That is the formula for pressure. Okay. Is that clear, all of you? Clear, clear, clear? No, still not visible. Now it's visible, no? Yes. Is it visible now? Students, all of you mark your attendance. Quickly, quickly, go like the video. Very few people have liked the video. How many people? Only 6 people have liked today's video. Quickly go give it a like. And also after the class, please comment under the session how it was, okay? So if a random person, all of you are Vedantu Karnataka students, but if someone who's very new, who he comes and sees the video, he or she comes and sees the video, he'll be like, it's a long video, should I click it? But if there's a comment, this is worth watching or this class is good, you will have a confidence. That person will have a confidence to watch it. Yes, all of us work that way, right? When we go to YouTube videos, we first check comments. So there has to be comments, okay? So please make sure you comment. Okay. Yes. So this is fine. Do you want me to do one more example? Okay, I'll do density also. Let's take density. Okay. So density dimension. So density is mass divided by volume. Now mass is what? The dimensional formula is m. Volume is just side into side into side. So side is what? Length. Length into length into length, or length into breadth into height. It's all lengths. So L cube. Yeah? L cube. So density's dimensional formula will be what? You tell me. Yes. Exactly the same thing. It will be m L raised to minus 3 t raised to 0. Because t is not there. Yeah? Okay? Thank you, Sanjay, for liking the video. Go tell all your friends also to like. Send this to all your friends who are preparing for KCET. Even if they're in first PU or second PU, ask them to study this. Okay. So this is density. How do I get volume as L cube? Volume is what? Side cube, or length into breadth into height, which is basically meter cube or centimeter cube. These are all length cubes. Okay. Yes. These are some dimensions. Now let's look at some KCT related questions. Where are those? Okay, I put them after this. Okay. Let's look at a question. The force acting on an object is given by F is equal to ma, where m is mass and a is acceleration. Find the dimensional formula of force. How will you do that? I already did that. F is equal to ma. So first you will write down the dimensional formula for m, then you will write down the dimensional formula for a. So this is basically mlt raised to minus 2. Okay? Yeah. Kinetic energy also I've already done. Okay? Yes. Now, there are some quantities that don't have dimension. Okay? So, those quantities are called dimensionless quantities. What are less quantities? They are quantities that have no dimension. So, for example, if they cancel off, for example, refractive index. So, what is the refractive index? Refractive index is the speed of light in air divided by speed of light in some medium. What is the unit of speed? Meter per second. What is the unit of speed in medium? Again, meter per second. So basically the same units, meter per second and meter per second, they cancel out. So there's no unit. If there's no unit, no dimension. Okay. So every physical quantity does not have dimension. Some have no unit, some have no dimension. Okay. Another thing I can give you is efficiency. Okay. So efficiency is what? Efficiency is output energy by input energy. Okay. Output energy by input energy. Output energy, what is the unit? The unit of energy is joules. Input energy also, the unit is joules. Joules and joules will cancel. So no unit, no dimension. Okay. So if a quantity has no unit, which means they are ratios of two similar quantities, they have no unit, they will have no dimension as well. Okay. So these are some examples of dimensional less quantities. So Poisson's ratio has no dimension. Coefficient of friction has no dimension. Strain has no dimension. Relative density has no dimension. Refractive index has no dimension. These are all some examples. Okay. Now before, yeah. Okay. So that was a KCET question. Thank you, Sanjay. Sanjay is too sweet today. Okay. Next. Sanjay, I want you to tell this to your juniors and your seniors and your friends. Okay. So we have more people. Our channel is a very small channel. Okay. Even YouTube hasn't recognized our channel. So only your love will help all of us, grow. Okay. Now, principle of homogeneity in dimensions. What does that mean? That means only quantities with the same dimension can be added, subtracted, or equated. For example, 50 kg of rice. Too obsessed with rice, no? I am also bored. Okay, 50 kg of chocolates and 5 centimeter box. You can't add those two numbers. Isn't it? What stupidity. I can't say 50 kg plus 5 centimeter is equal to 55. Can I say that? No. I can say, instead of this, I can say 50 centimeter plus 5 centimeter is 55 centimeter. Yeah. Or I can say 50 kg plus 5 kg is 55 kg. Okay. If they have the same unit, I can add them. Similarly, if they have the same dimension, I can add them or subtract them or multiply them. Just like with units, let's do the same thing with dimensions. Okay. Let's look at an example. For example, see, you can't add 5 meters and 3 kilograms, but you can add force. Okay. Okay, let's just take the example that's given to you. So the equation of kinematics, S is equal to ut plus half at square. How am I able to add ut and half at square? So to add that, ut and half at square should have the same dimension. Only then I can add that. What does that mean? So S is equal to ut plus half at square. Now in order to add that, ut and half you can ignore, constants are not considered. At square and S, all three should have the same dimension. Okay, all these three quantities should have the same dimension. Understood? Ut, at square and S, all these three should have the same dimension. Let's see if they have the same dimension. Let's do the math. So ut is what? Initial velocity into time. What is the dimension for velocity? L t raised to minus 1. Velocity dimension for time is t. So this in total is L. Oh, L. That's all. Minus 1 plus 1 is 0. So it is L. Okay. Now let's look at the dimension for at square. What is the dimension for acceleration? L t raised to minus 2. Dimension for t square is t square. So this will also become L t raised to minus 2 plus 2, which is L. Okay. Now is S. S is what? Distance. What is the dimension of distance? L. So see, all the three quantities have the dimension L. So now you're able to add them or subtract them or multiply them. Okay, this is the rule. If you want to add a quantity or multiply a quantity or subtract a quantity, they should have the same dimensions. Okay, this is called principle of homogeneity of dimensions. Okay, yes, all right. Now let's look at a KCET question based on the principle of homogeneity. If P, Q and R are physical quantities having different dimensions, which of the following combinations can never be a meaningful quantity? What does the question mean? That means that P has a different dimension, Q has a different dimension, R has a different dimension. So P could be LT raised to minus 1, Q could be M, R could be LT raised to minus 2. They three have different dimensions. So after you do the maths, they should have a meaningful quantity. Which one should be? So can you subtract two quantities which have different dimensions? For example, P minus Q. Imagine P is length and Q is mass. Can you subtract them? Definitely no, you can't subtract them. Yeah? Can never be a meaningful quantity. Yeah, L minus M. It can never happen. So this can never be a meaningful quantity. But can this be a meaningful quantity? Yeah, sometimes. See, imagine if R is ML, then P and Q are L and M. So this will be ML minus ML. Do you understand? Now here also, this could be ML by ML. So when you're multiplying and all that, they can be possible. But you can never add or subtract two different dimensions. I hope you understood this, If you're a student watching recorded, I just hope you've understood this because, if you were live, I could have answered your doubt then and there. Okay. So students, about my live classes, Sanjay. So for all the live classes will be scheduled very early. Okay, so what you should go do is you should go to Vedantu Karnataka YouTube channel. Okay, Vedantu Karnataka, and there'll be three sections: videos, shorts, live, playlist, and post. Under that, go to live. Yeah, go to live. In there, under live, all the classes will be scheduled, so you can see our pictures and the timing. Yeah. So right now, if you go to the live session, you will see all these classes are scheduled. So you can see tomorrow the solutions class on 13th at 19. The time is 6 o'clock. There is my class at 9 o'clock. All that you can see there. Okay. Yes. So that you can just use that. I don't know if you were able to see my screen, but yeah. Okay, so that's how you know when the next teacher's class is there. Anyway, like 2 days before the classes are usually scheduled. Alright, topic will also be there. Is this clear to all of you? Yeah. So what is the answer? This is the answer. Hmm? Yes. So P, Q, R are physical quantities. They have different dimensions. Which of the following can never be meaningful? You can't subtract two quantities which have two different dimensions. Okay. Next, check the dimensionless correctness of the equation V is equal to U plus 80. Okay. V is equal to U plus 80. How do we check if it's dimensionally correct? If it's dimensionally correct, then all these three quantities should have the same dimension. Okay. If it's dimensionally correct. So what is the dimension for velocity? L t raised to minus 1. Initial velocity will also have same dimension, L t raised to minus 1. Plus, what is the dimension for acceleration? L t raised to minus 2. What is the dimension for time? T. So, L t raised to minus 1 is equal to, again L t raised to minus 1 plus L t raised to minus 2 plus 1, which is basically L t raised to minus 1. Minus 1. So, all three terms have the same dimension. All three terms have the same dimension. Hence, they are dimensionally correct. Okay. So all three terms have the same dimension. So they are dimensionally correct. Do you understand? Similarly, you can do question 2 and question 3 also. You'll be like, ma'am, that's all the easy questions and gives the tough questions to us. Okay, let me do question 2 also for people who have that complaint. Okay, shall I erase this? Should I erase this or write it on the other side? Write it on the other side. Next formula. S is equal to ut plus half at square. Okay. S is equal to ut plus half at square. What is the dimension for S? S is length. So L. I think this I already did. Yeah, I already did this. U is what? L t raised to minus 1 into t. Plus half you ignore. You don't take dimension constants. For constants. Acceleration is L t raised to minus 2. Time is t square. So what happens? This becomes L. This also becomes L plus L. So if you're a student in PUC or CBSE, make sure you after this, you do these steps. After this, you should write LHS equals RHS. LHS equals RHS. So the equation is dimensionally correct. Like I wrote for the previous question. You have to write that. Okay? All three terms have the same dimension. Hence, they are dimensionally correct. Okay? Yes? Alright? Oh, yeah. And the third question for those of you, please don't look at this. Pause the video, go back, solve it, and come here and check if you've done it correctly. Okay? Yes? Okay. Now you'll also have questions where you have these kind of questions. Check whether half mv square is equal to mgh is dimensionally correct. How will you do that? Very easy. Half mv square. What is the dimension for half mv square? Mass is m. Velocity is L t raised to minus 1, no? Yeah. Smart kids. L t raised to minus 1. Okay. This is equal to, mass is again m. Gravity is what? Acceleration due to gravity. So gravity and acceleration due to gravity has the same dimensions. Into height is again length. Okay. Mass. Okay, square. Now let's write down, this becomes ml square t raised to minus 2 is equal to ml square t raised to minus 2. Same thing. So this equation is dimensionally correct. Okay. By now dimension should be clear to all of you. That equation is dimensionally correct. Next, applications of dimensional analysis. Where can we use dimensional analysis? So dimensional analysis helps us derive formulas. So it helps us derive the relationship between physical quantities. Okay. So just like how we did, okay, we can, find out the relationship between quantities. Now, for this is for your boards, not for your KCET. Yeah. For your KCET, you might, let's see. If there are questions, it will be there in this class. Okay. So imagine you get a question. Derive the formula for the time period T of a simple pendulum. So the question is, using dimensions, derive the formula. So that is one application of our dimensions. It helps us derive formulas. Okay. So what does dimensions do? They help us derive formulas. Now let's see how they help us derive formulas. So the question is, derive the formula for time period. So let's write down. I have to derive the formula for time period. Now time period is proportional to what all? Length. Time period is also proportional to gravity. Yeah, that might be given to you in the question. So this much things we know. We know that not a lot there. From this chapter, you won't get more than 2 or 3 questions. Okay. But see, 2 or 3 questions, also sometimes you will get only 1 question. Sometimes 2, depends. Okay. Not more than 3 questions. But that 1 and 2 question you can answer. That is why this chapter is important, because this is easy. Make sure you don't lose that 1 mark or 2 mark. Okay. So in first PUC, you actually don't have to learn all the chapters. You learn chapters according to their weightage. But this one chapter is very easy. So please don't skip this chapter. Okay. Yeah. Okay. Yeah. So the first thing that we know that time period is proportional to length. It is also proportional to gravity. These 2 things I know. Now, since this is proportional, what I will do is, first I will remove the proportionality, put an equal to sign, and then I'll put a constant. The constant might be 1, might be 2, it could be any value. So I'll just put k, and then it need not be proportional to L. It could be L square, it could be square root of L, it could be anything. So that could be a power. So I put L raised to A and G raised to B. This is the second step. Okay. So first step you write, whatever the quantity is proportional to what all? Then you put constant and power and then powers. Okay? Yes. T is equal to K, L raised to A, G raised to B. Next step is very easy. You will write down the dimensions. So what is the dimension for T? T. What is the dimension for L? L. Okay. K I will ignore it for now. Okay. For now I will just ignore K. I will just write. Yeah. The dimension for L is L raised to A. The dimension for G is acceleration due to gravity. So L raised to minus 2 into B. Okay. Now listen carefully. Okay. So now the equation that we have is T is equal to L raised to A L T raised to minus 2 into B. This is my equation. Okay. Yes. Now what I will do is I will equate the powers. So what is the power of T? 1. Okay. 1 is equal to, what is the power of T on the other side? Minus 2 into B. This is the power for T. So from this, can't I write B is equal to minus 1 by 2? Now, for L, on LHS, it is 0 is equal to L raised to A, so A plus L raised to B. This is for L. How did I do that? So here, basically this is L raised to 0, isn't it? L raised to 0. This is basically L raised to 0. So I am basically equating the powers. So 0 is equal to A plus B and 1 is equal to minus 2B. I equated the powers. Now here I already know B is minus 1 by 2. So A will be 0 is equal to A minus 1 by 2. So A will be plus 1 by 2. Okay. So now what all do I have? I have A is equal to 1 by 2. B is equal to minus 1 by 2. What was my equation? T is equal to K L raised to A and what was it? G raised to B. This was my first equation. Remember? Let me substitute the powers. So T is equal to K L raised to 1 by 2 G raised to minus 1 by 2. So this is basically T is equal to K L raised to 1 by 2 divided by G raised to 1 by 2. So this is T is equal to K square root of L by G. Square root of L by G. I should have done a better job in terms of neatness, but yeah. Is this clear to all of you? Yeah? So if you follow it step by step, you'll definitely understand. If you look at it like this, it does not look neat, but I'm sure I've explained all the steps. Thank you, Sanjay. Okay. I really understand. Thank you so much. Okay. Sanjay, please leave a comment after the class. Okay. Not in the live chat, but after a class. So when a random student comes and checks the video and sees a good comment, he or she will feel like opening the video. Okay. All right. Okay. Is this clear to all of you? So this is one application of dimension where you use it to derive formulas. Okay. Okay, there's another example. Derive the formula for centripetal force assuming it depends on mass, velocity and radius. So what is the first step? First step is you will write how it's proportional. So force is proportional to, in the question itself it says mass, but power you don't know. So m raised to A, velocity raised to B, radius raised to C. So this you will write it as F is equal to K m raised to A, V raised to B, R raised to C. This is the first step. Okay. The rest of the steps I will write it here. I think that's better. This is the first step. Second step, write down dimensions of all the quantities. Force is mass into acceleration. So ml t raised to minus 2. Mass is m. Velocity is distance by time. Distance is L. Time is t raised to minus 1. So L t raised to minus 1. And radius is just L. I don't by heart dimensions, okay? When I'm doing it, I just think about the formula and then I substitute. That's why, you see me thinking. I'm a person who I never by heart anything. It's very difficult for me. I don't know how many of you can relate with me, but biology was my most difficult subject, okay? Some of you may be like, ma'am, everybody loves biology, but I hated biology because I couldn't by heart stuff. So what I do is I always, connect and learn. Thank you so much, Lakshmi Narayana. All these comments mean really, really a lot to me, okay? So please do comment under the video as well, not in the live chat. Live chat I see and I'm very happy, but only if you comment under the video in the comment section, then other students can see and they can get motivated to watch our videos. Yeah? Thank you so much, Aditya. Today's live is very emotional, it seems. So many students are giving me wonderful comments. I love you all. So please send this to all your friends so I can teach for more than 3 students. Okay, Aditya? Yeah? Okay. Yeah. So so the first step is done. F is proportional to m raised to a, v raised to b, r raised to c. I remove the proportionality, put an equal to and a constant. Okay. Next step, I write down the dimensions. So I don't write down the dimension for a constant. I'll think about the constant only at the end now. Now let me write down all the dimensions as one big formula. So what will I write it down as? I will write it down as ml t raised to minus 2, which is force, is equal to, mass is what? Mass is m raised to a. Now velocity is velocity, instead of velocity I should write it as L t raised to minus 2. Instead of velocity I will write it as minus 1. L t raised to minus 1 raised to b. Instead of radius I should write this as L raised to c. Okay. Now I will equate the powers. So first I will take it for m. First I will take it for m. I think I should remove my head so you can see clearly. Yeah. First I'll take it for m. So for m, what will I do? What is the power for m here? It is 1. So 1 is equal to, what is the power for m here? A. So now a is 1. Next I will take L. What is the power for L here? It's 1 is equal to, here L has power B. So this is B and then there is C also, B plus C. Next is T. Here T has power minus 2 is equal to, there T has power minus B. So from this I can get B is equal to 1 by 2. If B is equal to 1 by 2, then what is C? Yeah, so this is basically 1 by 2 plus C is equal to 1. So C is equal to 1 minus 1 by 2, which is, what is 1 minus 1 by 2? Yes, it is 1 by 2. So I have C as 1 by 2. I have B as 1 by 2. I have A as 1. Next step, you should substitute this in your formula. So this is basically K into M raised to 1, V raised to 1 by 2 and R raised to C is also 1 by 2. Okay. So that's how you get the equation. So this is basically VR will be square root. Somewhere I went wrong. Minus B is equal to minus 2. Oh. How stupid students. Did you all notice this? Minus B is equal to minus 2. So B should it be 1 by 2? B should be 2. Yeah, superb. Okay, so here also it should be 2. Here also it should be 2. Yeah. Making mistakes is not a problem. We're all humans. Humans will make mistakes. But to find out the mistake is important. So 1 minus 2 is minus 1. Yes. Yes, Aditya. Okay, Aditya had already pointed it out. Oh, so happy to see that. Aditya had already pointed it out. Okay, so you have C is minus 1. We got that right. B is 2. A is 1. So we got all those three right. Aditya is recalling old memories. Okay. There were times when you used to sit at night and study all this, Aditya. So this is basically, let's see, change it here also. V raised to B. V raised to B. V raised to, what is B? 2. R raised to C. C is 1. Okay. MB square R. So the formula is F is equal to K into MV square by R. It should be minus 1. So minus 1 by. Okay. Yes. Yes. Is it clear to all of you? Sorry, I made some confusions. Simple mistakes. Okay. So B is 2, C is minus 1. And you will get the equation mv square by r. So you can say K is 1. So F will be mv square by r. Okay. Now for those of you who hate my handwriting, I know it's bad. I know I don't write neatly. You can just follow the printed version where it's all neat, crystal clear. Okay. Yes. Happy to have been part of your memories, Aditya. Thank you so much, Aditya. But please, we'll have to stop doing this until you promote us. Okay. So please make sure you send this to all your juniors. Tell them to learn from to teach. The whole channel. Yeah. Okay. I completed how many chapters? I think the first 3 chapters or first 4 chapters, Sanjay. But I'm doing them all again. This is KCET perspective. Okay. All right. Okay. Now, there are some limitations of dimensional analysis. These are all things all of you know. Yeah. See, if dimensions are given, the physical quantity may not be unique. For example, they could all have same dimensions because they all are represented by L, M, and T. If you look at torque and work, they have the same dimension. So there is no uniqueness in dimension. Okay. No uniqueness in dimension, and there is no dimension. It does not tell us about constants. So if we're doing this previous question, you might wonder, how will I know, ma'am, how K is 1? Some of you might have asked that question. Ma'am, you put K as 1, but how will a student who does not know the formula know K is 1? You can't know. Okay. That is one drawback of dimension. And for your exam, you did not know, you can just put it as K. So one drawback of dimension is you can't know any information about constants. They don't tell you anything about constants. Dimensions are not unique. And there are no dimensions for sine theta, no dimension for cos theta. Okay, no dimension for log 10. So logarithmic functions, trigonometric functions, all of these have no dimensions. And dimensions cannot handle too many variables. You can see in all the dimensions, I only took M, L, and T. There is no Z, X, Y. Okay. Only 3 quantities. So I can't take too many quantities. Okay. And dimensions also don't give you the direction. See, by looking at the dimension of velocity, you can't look at the direction. It only gives you dimension. It does not provide any information about the vector part of it, which means the direction. What does vector mean? A quantity with magnitude and direction. So you can't have any information about the direction. Okay? Oh, I had put some questions for. Yeah. Next question. Which of the following expression, this is also a KCET question, which of the following expression can be deduced on the basis of dimensional analysis? Yeah. Which of the following expression can be deduced on the basis of dimensional analysis? What is the answer? Where is my Aditya? My senior. Let me know. What is the answer? I just asked Aditya because he said he finished his 12th. So let's see if he remembers. That's why, okay? Uh-huh. Okay, which of the following expression can be deduced on the basis of dimensional analysis? As I already said, trigonometric formulas do not have dimension. Exponentials do not have dimension. So which can be deduced by dimensional analysis? Mhm. Yeah. Okay. So here you can see. Let's look at this question. Let's look at this one. The first two, anyways, they're eliminated. Now for this one, you can say that f is proportional to what are the quantities? Eta raised to a, r raised to b, v raised to c. And then if you write down the dimensions for each, you will actually see that it has dimensional formulas. See, a, b, and this actually d is also possible. Okay, anyway, let's do it. 6 pi is a constant, so you ignore it. So what are the dimensions for force? M, L, T raised to minus 2 is equal to. What is the dimension for eta? Eta is, so you all should derive and tell me, okay? So here it will be M, L raised to minus 1, L raised to minus 1, and the thing will be T raised to minus 1. R is just length, so L, V will be L T raised to minus 1. So A, B, C. And then you equate all of it. Now I'm not going to write all the steps. So M is just 1 is equal to A. Then B will be what? L minus 1. B, C. So 1 is equal to minus A plus B. Minus A is what? Minus 1. Minus 1 goes to the other side. Minus A plus B, right? Okay. C is equal to minus 2 is equal to minus C. So C should be 2. Hey, there's something wrong in this question. -1 -2 minus A. Nothing is wrong with the question, something's wrong with me only. 2 days full chocolate. Missing Baswaraj sir. Baswaraj sir takes classes now. You can watch Vedantu Karnataka live. He has classes, okay? He's not gone anywhere. Okay. So for M, what was it? 1 is equal to A. Yeah, perfect. Now for L, 1 is equal to minus A plus B plus C. Okay, perfect. Now for T, minus 2 is equal to minus A minus C. Okay. Now from this, minus A is -1. So minus 2 is equal to -1 minus C. Whole thing I can actually add it. Okay. So this will become 2 minus 1 is equal to C. So C will be 1. Okay. Now, in this, I will substitute it in this equation. So this will be 1 is equal to -1 plus B, I don't know, plus 1. So this 1 and 1 cancels. B will also be 1. So A is 1, B is 1, C is 1. Let me substitute that here. A is 1, B is 1, C is 1. A is 1, B is 1, C is 1. So this will become F is proportional to eta R V, all raised to 1. Now, if the constant is 6 pi is equal to K into, so K will be 6 pi. So I get the equation C. Okay. So I was able to deduce the equation using dimensional analysis. That was possible only for equation 3. Okay. So for equation 4, why can't I use it? See, from S is equal to ut plus half at square, I will not be able to derive the dimensional formula. Okay. So because it has 2 terms, it will be very difficult. Deriving dimensional formulas is only possible for single term quantities. Okay. Oh yeah, Aditya, I'll definitely tell Baswaraj sir. Okay, there was a comment. Yeah. Okay, I'll tell Baswaraj sir. Don't worry. All right, is this clear? Why, why equation 1, 2 and 3 are wrong? 1 and 2 are wrong because cos and exponent have no dimensional analysis. Third one, because you're adding 2 terms. You can't find a dimensional formula from that. You can prove correctness for that, but for dimensional formula, only for C it's possible. Okay. Next question. This is also a previous year KCET question. Sorry. Derive the dimensional formula for radioactivity, for activity of a radioactive substance. Okay. Dimensional formula for activity of a radioactive substance. So to do these questions, students, one thing you need to know is you need to know the formula. Only then you'll be able to do it. Okay. So that's the only challenge for dimension. Only if you know your formulas well, you can do it. Otherwise, it's a very easy topic. For everything, there is a but, no? Yeah. So, see, the activity is independent of mass. See, what is the activity? It is how much radiations a radioactive substance emits. It does not depend on mass. It does not depend on time. Length, it only depends on time. Okay. So, the dimensional formula for activity is basically how much it disintegrates in a unit interval of time. So, basically, activity is proportional to time. So, what should the dimension be? There is no mass. So, m raised to 0. There is no length. L raised to 0 and T raised to minus 1. So what is the option? Which option is that? Option C, right? Yes? Option C, no? Yeah. It is option C. Very easy. Very easy. Yes. So this question you will be able to answer only if you know that activity is inversely proportional to time. That means as time increases, activity decreases. See, for a radioactive substance, it keeps on emitting radiation. After a long time, it will emit little radiation. Initially, it will emit a lot of radiation. So as time goes by, uh, the radioactivity will decrease. Okay. Bye, Aditya. Please make sure you tell your juniors to watch the lesson. Okay? So these are all previous year questions from dimensions. Okay? Next, what we have to look at is we have to look at significant figures. So before we look at significant figures, I'll give you a 10-minute break. All right? So let us resume back at maybe 10:50, 11:05. Okay? So we'll have a 15-minute break and then we'll continue with significant figures. Hello students, welcome back. So we were looking at significant figures. Let's welcome back. Okay. So significant figures are basically, it just tells us how many figures are important in a certain number. Okay. For example, the number 5. If you look at the number 5, for the number 5, 5 is a very important number. So it has one significant figure. Okay. So not all, the idea here is that not all terms in a number are significant. Okay. If you quickly mark your attendance. So for the attendance poll, there are 28 votes. Okay. And the likes are only 8. What is that, students? Yeah. Yes, Sanjay. Okay. So 5 has one significant figure. Now, 50. 50 has how many significant figures? 50 also has only one significant figure. Now, 500 also have only one significant figure. 5,000 also has only one significant figure. Okay? So, zeros after a number are not significant. There are actually certain rules to this. Let's look at the rules one by one. Okay? So, first thing is that all non-zero digits are significant. That's a rule that all of us anyway know. If I have a number 56, it has two significant figures. If I have 567, it has three significant figures. If I have 5, 6, 7, 8, it has four significant figures. Okay, so depending on the number of numbers, the number of significant figures will increase. So all non-zero digits, they are all significant. Okay, so all non-zero digits are significant. Okay, next is zeros between two non-zero digits. Are they significant? Let's look at the examples for that one. For example, if you have a number 106. Now 0 is between 1 and 6. Yeah. So this is not, sorry. This has how many significant figures? This has how many significant figures? Three significant figures. If I have 1006, it has four significant figures. So, zeros between two significant numbers are significant. Okay? Alright? So, if you have zeros between two significant numbers or two non-zero numbers, then those zeros are significant. Okay? Now, next rule. Next rule. Leading zeros before first non-zero digit are not significant. Okay. So, if you have a number 0.0025, 0.0025 has zeros before a non-zero digit. The non-zero digit here is 2 and 5. So, these are not significant figures. This is only two significant figures. 0.05, one significant figure. 0.32, two significant figures. So zeros before a number Okay. Before leading zeros, before the first non-zero digit is significant. Okay. Yes. 0.00005. How many significant? One significant figure. All right. Okay. Next rule. Let's look at the next rule. Trailing zeros after a decimal place are significant. Okay. Trailing zeros after a decimal place are significant. For example, 1.0 has two significant figures. Okay. 2.300 has four significant figures. 1.150 has four significant figures. Okay. So zeros after a decimal are always significant. Okay. But 0 after a regular number is not significant. For example, 500 has only one significant figure. Okay, so students understand the difference. 5.00 has three significant figures, but 500 has only one significant figure. So if the zeros are after a decimal, then they are significant. If the zeros are after a number, then they are not significant. Okay? Yes. Is that clear to all of you? Nothing special, Sanjay. Just normal food, okay? Huh? What did you eat for dinner, Sanjay? Is this clear to all of you? Yes. Is this clear? Okay. Yes, so these are the different rules for significant figures. Okay. So quick quiz. Quick quiz. I had a quick quiz. Yeah, here. Quick quiz. I want all of you to pause the video and quickly solve this if you're watching it recorded. Yeah. So 507, three significant figures. This will have how many? Two. Yes, very good. This will have one. Yes. So the rest you can eat. I mean, you can do. Sorry. I read, Sanjay ate gobi rice for dinner, and then that's why I said this you can eat. Okay. Narasimha, hi. Now, what else? Exact numbers in scientific notation is not that important. See, exact number is when the quantity is defined exactly. Okay, for example, there's no uncertainty. For example, 10 apple. 10 apple means 10 apple. There is no, it could be 9, it could be 11. No, 10 apples means 10 apples. That's exact numbers. Okay, so for scientific notation, you're like averaging. It's like a range that you're giving. Okay, okay. Yeah, so for all those who solved the significant figures, you can look at the answers here. Okay, if you got all of them right, put got all of them right in the comments. Yeah, I'll be checking how many of you got all of them right. So you should put got all of them right. Okay, next are some rules to round off significant figures. What are the rules to round off significant figures? So if the digit to be dropped is less than 5, then leave the last digit unchanged. For example, 3.42. Okay. So if the number is 3.42, what is the last digit? What is the last digit? The last digit is 2. So you can check if 2 is less than 5 or greater than 5. 2 is less than 5. So you can just drop it. So this will be equal to 3.4. Okay. Yeah. Narasimha, important questions we've already done, dear. Are you in first PU or second PU? You can just watch Vedantu Karnataka the videos, FA1 or unit test videos we have done for every single topic. Yeah. Okay. Okay. Next. Next, if imagine the number is 3.48. Now look at the last digit. What is the last digit? It is 8. It's obviously greater than 5. So what should you make it? You should round it to 3.5. Okay? Understood? 3.5. Now, next 9.947. So let's look at the last digit. What is the last digit? It is greater than 5. Yes. So you can round it to the next number. So this will be 9.95. Okay. Hmm? Is this clear, all of you? Yeah. Ma'am, clarity is not there. I think it's because of your internet, Nayak. Because on my phone, it's clear. Clarity is there. Okay. I think it's because of your internet connection. Just or you go to settings and increase the quality. Okay. Yeah. Next. What happens if the digit to be dropped is exactly 5? In that case, what happens? So if it's 2.65, that is the digit is exactly 5. So what you should do is, if the second last number is even, you round it. Okay. So 2.65. 6 is even. So you write it as 2.6. Now if it's 2.75, 7 is odd. So you will write it as 2.8. Okay. So if the second last digit is even, you leave the 5. If the second last digit is odd, you round it to the next digit. Okay. So that is what I have done here. So here if 6 is even, you drop 5. If 6 was odd, you will round it. So 7 is odd, so you round it. Okay. Now, operations with significant figures. How do you perform operations with significant figures? Let's look at multiplication. For example, 2.5 into 2.5 into 3.42. So what will it be? I'm not doing it now. I've already solved it here. So I'm looking at the answer. So it's going to be 8.55. But my answer should have the number of significance. My answer should have a number of significant figures which is the same as the lowest in the multiplicants. For example, here which one? 2.5 is 2, 3.42 is 3 significant figures. So which is greater, 2 or 3? 3. So the least one should be the answer. So my answer should have 2 significant figures only. Understood? So this has 2 significant figures. This has 3 significant figures. So answer should have 2 significant figures. Okay? So answer should have 2 significant figures. Now 8.55, the last digit is equal to 5. So I should look at the digit before that. 5 is odd. So I should round it to the next number. So I will get it as 8.6. Okay. Is that clear? It will become 8.6. Next, 10.50 divided by 3.5. This is equal to how much? You will get 3.0. See, your answer will actually be 3. Your answer will be, you won't do 3.0 and all. You will get 3. But your answer should have 2 significant figures because here the least number of significant figures is 2. So you should write your answer as 3.0. Okay? Next for addition and subtraction. Let's try addition and subtraction. 12.11 plus 0.3 is equal to 12.41. But should it be 41? The answer should have only 2 significant figures. So it will be 12.4. Okay? Yes? Yeah. Next, 25.678 minus 2.3. Okay? So the answer should have 2 decimal places. So this will be 23.378. So you can round it off to 23.4. Actually, you can write it to 23. 23 is enough. Okay? If we buy Vedantu NEET modules, is it beneficial? Definitely. See, Vedantu NEET modules are made by teachers who have been teaching NEET for so many years. Okay, so they're like very experienced teachers from IITs and NITs. They have prepared the Vedantu NEET module. Okay, so it will definitely be beneficial for you. Okay, yes, because they've been doing this for a lot of years. They know what comes, what will not come, and all that. And make sure you follow the lessons. Just buying the module won't help you clear net. You should buy the module, work it out, and follow the lessons. Okay? Only then it will be beneficial. Fully. Okay. Next exercise for you. I want all of you to quickly pause the video and yes, dear, it will be available on the website. Okay? I'm not sure if there's a link in the description also to buy that. Yeah, you can just send an inquiry on the link in the description and they will definitely get back to you. Okay. Yeah. So next, some operations with significant figures. You have to round the answer to correct number of significant figures. So those who solved it, the answers are here. If you've done it correctly, right, got it all correct, ma'am, in the description. I mean, in the chat, in the comments. Okay. Yes. How are you all doing so far? So far, good. Now let's do a KCET question. Since we've learned this much, let's do a KCET question related to this. Okay, what is the question? A substance of mass 49.53 gram occupies 1.5 centimeter cube of volume. The density of the substance in gram per centimeter is to minus 3 with correct number of significant figures is. Okay, that is the question. What is the answer? Who's going to tell me the answer in the comment section? So first thing you have to calculate. Let's calculate. What is the formula? Formula. I have to find out. Density. Okay. So density rho is mass over volume. Now this is in CGS unit. CGS. So I'm not going to convert it. So if one was centimeter and the other was kilogram, then I should convert it. Okay. So now it's centimeter and gram. They can go together. So I can write it as 49.53. The whole divided by 1.5. So 49.53 by 1.5. You should get 30. 49 will be 50 by 15. So you will get something like 33. Okay. So 33.02 maybe. Okay. Yeah. So what should the answer be? Definitely not 3.3. Not 3.300. Not this. The answer will be 33.0. Okay. Yes, with correct number of significant figures, it should be, you might get 33.02, something like that. So you should get, your answer will be 33.0. Okay, well and good. Is that clear to all of you? Any doubts anywhere? Simple concepts, right? When are you going to sleep, Sanju? I think all the students or most students have their physics FA1 tomorrow, I think. So all of them are busy studying, I guess. So in under tomorrow's class, I might see a lot of messages saying, ma'am, yesterday was my physics exam. Let's see. Okay. Next. Yes, Sanju, it's D. Very good. We're going to finish off the class. Okay. Soon. We'll finish in like few more minutes. Last topic of the day is least count. Okay, we have errors also. Yeah. Least count. Okay. So least count is the smallest measurement that can be taken accurately with from any instrument. For example, if you take a scale, okay, if you take a scale, the smallest measurement that you can take, all of you can take a scale, go pause the video, go take your scale and come. On your scale, the smallest line, what does that represent? This represents 0.1 centimeter or it represents 1 mm. Right. The small scale, the line represents 1 mm. 10 line like that gives you 10 mm. So the smallest measurement that you can take with your scale is 1 mm. Okay. So that is the least count. Least count is the smallest value you can measure on a scale. Okay. So for a normal scale, it's 1 mm. For a vernier caliper, it's 0.1 mm. For a screw gauge, it is 0.01. For a stopwatch, it is 1 second or 0.01 second, whatever. Okay. So this depends on the different components, and this you need mainly for your lab exams and all. You will definitely need vernier and screw gauge. Okay. But I have seen a question in your previous year KCET also. That's why I've included this. Okay. So if you would have a screw gauge here, this is a screw gauge. Okay, let me see if you can see the screw gauge because of my head. So I keep my phone in front of me. So I see what you see because on my screen I don't see myself. I only see the presented part. I think you can see. Yeah, you can see. Okay, so this is a screw gauge. So to find out the least count of the screw gauge, what you have to do is you have to divide the pitch of the screw gauge divided by number of divisions on the circular scale. Okay, so this is the circular scale. This is a circular scale. How many divisions are there? Most circular scales have 100 or 50 divisions and then pitch divided by that. So this is a screw gauge with 100 divisions. So it's 1 by 100. Okay, so pitch is how many rotations it can move. Usually in one rotation, it will cover all the 100 or all the 50. So 1 by 100. Now if on the pitch, if there are only 50 lines, it will be 1 by 50. Okay. Now to measure the thickness, it will be MSR plus CSR into LC. Now vernier calipers, they also have two scales. Okay. They have the main scale and the vernier scale. Least count is basically one main scale division minus the value of one vernier scale division. Okay. This one. Okay. Now we'll look at errors. What is errors? This is the last topic of the day. Okay. I'll send you all to sleep in some time. Errors questions are, very common in KCET. Errors, dimensions, significant figures, all of those are important things, but things that you can easily do. Okay, so errors in measurement. So, error is basically a difference between the true value of something minus the measured value of something. Yes. So, if you have a positive error, that means the measured value is less than the true value. If you have a negative error, that means the measured value is greater than the true value. Okay. So imagine let's say the actual length of this pen is 15 centimeter. Okay. And you measure it and you tell me, ma'am, I got 14.5. So your value is actually less than the actual value. So you have a positive error. Now another student comes and tells me, ma'am, it's 15.5. So he has a negative error because he measured a greater value than the actual value. Okay. Now there are so many kinds of errors. Absolute error is there. What is absolute error? true value minus measured value. As I said, this is actually 15. If you get 15.5, 15 minus 15.5 is your absolute error. Okay. Now, percentage error is basically absolute error divided by true value into 100. So, absolute error was how much? The actual pen was 15 and then he measured it as 15.5. So, the error is 0.5. So, 0.5 by the actual value, which is 15. So, 0.5 by 15 into 100 is my percentage error. Okay. Yes. Now, the rules of error propagation, how you can write errors. This is very important. There's a question related to that, which I'll tell you. Now, if you have, if you're doing Q and you're adding, Q is basically A plus B or A minus B. Okay, let's take A plus B. Okay. Now, the absolute error here will be del Q is equal to del A plus del B. So, del Q is the change in Q's value. Del A is the change in A, del B is the change in B. Okay. Now, if you're doing multiplication or division, what you'll do is, imagine you have Q is equal to A into B. Okay. Q is equal to A into B. So, del Q is the error. So, del Q by Q will be equal to del A by A plus del B by B. This is a very important formula, students. Even for NEET, okay, even for NEET, you will get a lot of questions based on this formula. Okay, so this is the formula. So if you have Q is equal to A into B or Q is equal to A by B, if they are asking you for error, you should write it like this. Okay, for both Q is equal to A into B and Q is equal to A by B, you should write it like this. You should write del Q by Q is equal to del A by A is equal to del B by B. Okay. Yes. Is that clear to all of you? Hmm? Now, if there is a constant, such that Q is equal to K into A. So then how will you write it? You will write del Q is equal to K into del A. Okay. Now, if there is a power, that also you have to address. If there is a power, so if Q is equal to A raised to N, then how do you write that as? That will be written as del Q by Q is equal to N into del A by A. Okay. Del Q by Q is equal to N into del A by A. That's how you should write it down. Okay. Yes, yes, yes. No. Okay, let's look at an example question. One simple example question we'll do. Okay. Yeah. So the question is, what is the question? Length L is equal to, okay, L is equal to 2 plus or minus 0.1 meters. Okay. Breadth is equal to 3 plus or minus 0.2 meters. And area is equal to length into breadth. Find out the error in A. So the error in A, for the error in A, the formula that you should be using is delta A by A is equal to delta L by L is equal plus delta B by B. Okay, that I've not done here. Okay, anyways, let's substitute that. Okay, let's substitute that. So what is delta A by A? We don't know. We don't know delta A by A. area we can find out by length into breadth. So what is it? 3 into 2, 6. 6 meters square is your area. Okay. Now what about your length? How much is it going to be? Here what I will substitute. Delta L is what? Point. I think you might not see because of my head. Delta L is what? 0.1. L is 2 plus. Delta B is what? 3.2 divided by 3. So this is basically 0.05 plus 0.067. This is 0.017. Okay. So delta A by A is 0.017. So what is delta A? This is 0.017 into 6. So this is basically 0.7 meter square. Okay. Yes. So delta A is equal to 0.7 meter square. Did you understand? Let's do one more. Okay, so what will the final answer be? Answer will be, area will be what? A plus or minus delta A. So it will be 6 plus or minus 0.7. Simple as that. Let's look at another question. Calculate Q. Q is equal to A into B into C. Okay. So first thing what we'll do, we'll calculate Q. Q is basically 5 into 3 into 2, which is 30. Okay. Step 1. Now let's write down the formula. So delta Q by Q is equal to delta A by A plus delta B by B plus delta C by C. Okay. So delta Q divided by Q is 30, which is equal to delta A is 0.2 by 5 plus 0.1 by 3 plus 0.05 by 2. Now if you do this much, you should be getting 0.098. Okay. So this will basically be delta theta is equal to 0.098 into 30, which is 2.94. So Q is equal to 30 plus or minus 2.94. Okay. Are you all with me? Do you all agree? Yes? Yes? No? Okay. Very good. Okay, there's another question which you can definitely solve by yourself. Same kind, right? So I want you all to pause the video and quickly solve it. So there's a metallic plate and it has 3 dimensions: length, width, and thickness. So you have to find out the volume of the plate and the absolute error in the volume measurement. So volume is basically length into width into thickness. Okay. So volume is equal to length into width into thickness. So this is basically 25 into 15 into 2. Okay. So when you multiply it, you will get the answer. And then what should you do? You should do delta V by V is equal to delta L by L plus delta W by W plus delta T by T. Okay. And then if you do the math, you will get it. Same steps. Okay. So this is a previous year KCET question. Let's solve it. A cylindrical wire has a mass of 0.3 plus or minus 0.003 grams, a radius 0.5 plus or minus 0.005 mm, and length 6 plus or minus 0.006 centimeter. The maximum percentage error. Okay. How do you do that? Maximum percentage error. Okay. Let's solve it. So first thing, let's write down the formula. Here you have density, right? You have to find out density. So density Density is represented by rho. So density I will put rho. So rho is equal to mass over volume. Now volume is not given to me. So what will I write? It's a wire. So volume will be pi r square L. You should know these formulas. Only then we'll be able to do this question. Okay, it's going to be pi r square L. Now let's see how you write it in an error equation. So what you will do? You will do delta rho by rho is equal to delta m by m plus pi is a constant, totally ignore. R square, what will R square become? 2 into delta R by R plus delta L by L. Okay? So this is how you write errors. Understood? So however complicated the formula is, multiplication division you don't bother. If there's a power, you multiply that in front. You simply add it like this. Okay? Now this is all you need it in percentage, right? So you multiply everything in 100. Okay? You multiply everything with 100. So into 100, into 100, into 100, into 100. Now let's do that. Density value I don't know. So delta P by P is equal to M is 0.003 by 0.3 into 100 plus 2 into delta R is 0.005 divided by 0.5 plus into 100. This is into 100. Into 100 plus 0.06 by 6 into 100. So this is very easy. Cancel, 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 cancel. What will it become? 1 plus this will be 2 plus 1. So this will be 1 plus 2 plus 1, which is 4%. The answer is D. Okay. So for those of you who didn't see what I wrote, it's going to be 4. Okay. Yes. Thank you so much, Sanjay, for staying back and, for all the messages. Okay. Thank you. Thank you. No, all of your support, it actually means a lot. Okay, I've already typed the answers here. You can look at these answers as well. Okay. Yes. Oh, is this another question? No, same. Wait. Calculate volume 750. Oh, yeah, this is the solution to this question. Okay, students. So, this homework question that I have given you, for those who have finished working it out, the solution is here. Your answer should be 0.5 plus or minus 0.01. Okay, this should be your answer. So, these are the steps. So, first thing what you do, you will calculate volume. How will you calculate volume? Length into width into thickness. So 25 into 15 into 2, you will get 750. And then you equate it. What will you do? You will do del L by L is equal to 0.08. And then del W by W, del T by T. And then what will you do? You will write down the formula. Del V by V is equal to del L by L plus del W by W plus del T by T. Okay. And then what else? Yeah. So whatever answer you get here, what are you getting? So del V by V will be equal to 0.0397. You should get that. So del V is equal to, how much is V? 750, no? Yeah, 750. So this will be 750 into 0.0397. So del V is equal to 29.8 centimeter cube. Now, how will you write down the final answer? Volume. The final answer you will write it as V is equal to 750, which was your value of volume. No, I get confused. I said volume, okay, plus or minus your error bar. How much is your error bar? It is 29.8. Okay? Okay? Is this clear? Is this clear to all of you? Okay? I think Sanjay is the only one in class, Sanjay. Yeah, we can definitely meet. Okay, so there are these Vedantu meetups where we can meet each other, where we all teachers come and then it's open to students. Okay, so when those events come, I'll let you know. We can meet each other. Okay, is this clear? So in this class, what all did we see? We looked at what all did we look at? We looked at dimensions. Very important. But before that, first we looked at what is physical quantity. Okay. And then we looked at derived physical quantities and fundamental physical quantities. Okay. Derived, fundamental. We also looked at a supplementary physical quantity, solid angle and steradian and radian. And then we looked at dimension, very important. So from dimension, you get a lot of, KCET questions. I mean, not a lot. Every year, I usually see some KCET questions. So dimensions are there. Then we looked at significant figures. We looked at the different rules for dimensions. So if it's someone who is going to write your PUC or your CBSE exam, you need to know those rules, okay? You need to know the rules for significant figures, rules for dimension. You need to prove that the LHS equals RHS. Prove the correctness of a formula or prove that an equation is dimensionally correct. Okay? All of those things you should prove. Then, what else did we discuss? We looked at significant figures. Then, let me know what else did we discuss? Dimension, significant figures. We looked at errors. Okay, how to solve questions with errors. What is the formula? Del A by A. If A is equal to B into C, del A by A is equal to del B by B plus del C by C. Okay? Yes? Students, quickly, all of you, did you all mark your attendance? So if you've watched this video till here, yeah, till here, you're awesome. Okay, you've done fundamentals of, units and dimensions. Anything you get in KCET, you will be able to solve it. Yeah, because I'm sure the concepts are clear to you now. So whatever question whatever question that comes, you'll be able to solve it just like that. Okay, so this chapter does not have a high weightage, but it can give you questions that you can't go wrong with. So make sure you never skip portions like that. See, some portions are tricky and there are not a lot of marks from it that you can skip. See, KCET is not about, dying hard and studying. It's about studying with strategy, studying smart. Okay. So this is a chapter where you can score. So please don't skip on this chapter. Yes, Sanjay, only you and I are present in class. Yes, yes, yes. Now, there are some more students. I can see some more attendees. Okay, but I don't know who they are. Whoever is watching the class, can you say hi so I can see who you are? Okay. Now, also, students, once again, I'm going to remind you about our Mega Vedantu Scholarship Admission Test. Okay, so it's a huge event. A huge event, as in you get a chance to become a national champion. Imagine how great is that. Okay, the only thing you have to do is start preparation. Okay, make sure you revise your portions fast. I mean, not fast, thoroughly. Come for the offline exam. When is the offline exam? It's on 4 days. What are the 4 days? Is 4th, 5th, 11th, and 12th of October. Okay, so you have some time. Brush up everything. Be all prepared. Come for a scholarship admission test. You can get all India ranks among 2.5 lakh test takers. Okay, you can get up to 100% scholarship on all Vedantu courses. And Vedantu courses, once you have them, you'll be very thankful because they're the best. So in all these years, we have proven that. You can get 150 rupees crore worth scholarships. You can get rupees 2 crore worth of cash prizes, free online material, free study material, one-to-one counseling, all of that. Okay. So don't miss out this wonderful opportunity, students. This is the Mega Vedantu Scholarship Admission Test. It happens only once a year. So please don't miss out on that. No offline centers near Yelahanka, Sanjay. Offline center in Bangalore is at JP Nagar. Okay. So if you're looking for offline sessions, you can go to our JP Nagar center. But no offline centers in Yelahanka right now. Okay. But we'll soon have them. Is that fine? Okay, so that's all for units and dimensions. I think we've covered pretty much everything. Yeah, we've covered everything. So that's all that you need to know from your first PU for units and dimensions. Okay, is there anything else? And students, please let us know in the comments on how the class was. Okay, because we all of us teachers are working really hard just to ensure that you get the best. Okay, so there are a lot of YouTube channels, a lot of people giving you content, but we make sure that you get content for everything. See, what exam you have, you name it, we have videos for that. Your exam 1, exam 2, exam 3, you can ask your seniors. We taught them for even exam 3 and the last supplementary exam, which was exam 3. Yeah, for your FA1, we had done a whole series. For your first unit test, whatever exam you have, you name it, we have that done for you. Okay, so please do support our channel. Yeah, and how do you support? Very simple. You share these videos to your friends so that they know that such a channel exists and they can send it to their friends. So we reach a huge network. Okay, also subscribe, like, and share. Okay, and please let us know in the comments on how the class was, students, so we know how to improve it or what you want. So we interact with each other. Not everybody watches the video live. You might be someone watching it recorded. So please mention that in the comment section as well. Okay, so bye-bye. I'll see you with another video. Take care. Good night. Bye-bye.